Happy morning, my dear children. Yesterday assignment many of the wrote. If you are learning one question per day, we can score very good mark. It is very helpful during the revision time. Okay. Anyhow, today our learning objectives to learn about the magnetic properties. To learn about the magnetic properties of 3D elements. That means magnetic moment. We are learning by magnetic properties. We are also calculating the magnetic moment. Anyhow, today learning objectives to learn about the magnetic properties of 3D elements. Okay. Here, the electrons are spinning around its own axis. The electrons is spinning around its own axis. They have some moment. Due to the motion, a tiny magnetic field is generated. Due to its motion, a small type of a tiny magnetic field is generated, and we can be measured by means of magnetic moment. Okay, how much amount we get by means of magnetic, we can be measured by means of magnetic moment. Here, this can be classified into four types. One is paramagnetic material. Second one is diamagnetic materials, and also beside this there are another more having ferromagnetics and also antiferromagnetic materials. What is about the diamagnetic materials? Here a species with all electrons are paired. Here all electrons are paired. Paired means we are saying diamagnetic. All electrons are paired means diamagnetic. The materials with no elementary magnetic dipoles are called as diamagnetic. Here, these kinds of the materials are repelled by the magnetic field because the presence of external magnetic field. Presence of an external magnetic field. Next about the paramagnetic having unpaired electron. Paramagnetic means they are having not paired electron, unpaired electron. Unpaired electron, and also here tell about that the absence of external magnetic field, the dipoles are arranged randomly. Okay, the dipoles are arranged randomly, and hence they are shown in the no net magnetism. No net magnetism. Next about the ferromagnetism. Ferromagnetism means the materials which have the permanent magnet and they are attracted by the magnet. They are called as ferromagnetism. Okay, and we can learn about the magnetic moment of the 3D element, magnetic moments. That means we have one formula. What is the formula means? Mu is equal to root of n into n plus 2. N into n plus 2. By we can calculate how much electron present in the d subshell. For each ions, in 3D series having many ions, each ions having how much electrons in the 3D subshell. So we can be calculated by use of this magnetic moment formula. Please all of you take a note. We can be write how much electrons having in the 3D subshell for each ions. Please all of you take a note. The magnetic moment of the ion is given by one of the formula. The magnetic moment of the ion is given by mu. Mu is equal to G into root of S into S plus 1. Here mu is equal to G into root of S into S plus 1 mu B. That is Bohr magnetic charge. Okay. Here, but we can be calculate the magnetic moment of the ion. The formula is mu is equal to G into root of S into S plus 1. Where what is the meaning of S means? Here S is the total spin quantum number of the unpaired electron. What is about the S? S is the total spin quantum number of the unpaired electron, and about the mu B is a Bohr magnetic charge. Okay, and about for an ion, we are taking for an ion with n unpaired electron. N unpaired electron, that is S is equal to n by 2. S can be written as n by 2. For an electron G is equal to 2. For an electron G is equal to 2. Therefore, the spin magnetic moment is given by the formula. The spin magnetic moment is given by the formula mu is equal to 2 into root of n by 2. That is, yes, we are writing n by 2 into, for this, yes, n by 2 plus 1. Okay, and also mu b, both magnetic torque. Clear? And also we can written as another one formula, mu is equal to 2 into root of n into n plus 1. N into n plus 1 divided by 4. Can be written as n into n plus 1 divided by 4 Bohr magneton. Can you write? And also mu is equal to root of n into n plus 2. n into n plus 2 Bohr magneton. These are the formulas, okay, to calculate the magnetic moment. Okay. Next, how can you calculate the 3D series, that ion of 3D series with configuration, D configuration? How can you calculate? So these are all the one-word question. These are all for the one-word question. Calculate the configuration for 3D series ion. For example, we are taking Sc3+. That's a scandium. It loses 3 electrons, and also titanium loses 4 electrons. That is Ti4+, and also vanadium about V5+. What is the configuration? Clear? What is the configuration of scandium Sc3+, titanium Ti4+, and vanadium V5+? What is the configuration and how much unpaired electron that you are going to calculate? First one, I am taking the scandium. Scandium atomic number is 21. Okay, the atomic number of scandium is 21. Here, the electronic configuration of scandium is, that is argon 3D1 4s2. Am I right? Argon, the atomic number is 21. Argon goes to 18 electron. What is the remaining electron? That is 3D1 4s2. Here, our question is scandium. Scandium, the electronic configuration we are going to write. Okay. Here, first of all, we are writing 3D subshell. How much electron is there? 3D, only one electron. About the 4s, how much electron? 2 electron. Am I right? Here scandium 3+, that is loss of how much electron? Loss of 3 electron. So that is here 4s electron, the 2 electron is lost, and about the from 3D subshell, how much electron? The 1 electron is lost. So it have scandium Sc3+ means have a D0 configuration. Which configuration? D0, because loss of 3 electron. Become a D0 configuration. Here we can calculate the mu. Here number of unpaired electron. There is no unpaired electron is there, because actually losing the electron, so D cells are vacant. So we can written as mu. Mu is equal, what is the formula for mu? Mu is equal to root of n into n plus 2 Bohr magneton. That is mu b. Okay, Bohr magneton. Okay, here we get the configuration, that is D0. Am I right? The loss of electron D0. So we get mu is equal to number of electrons, that is 0 into 0 plus 2. Okay, is equal to 0 mu b. Okay, clear? Then unpaired electron is 0. So we get 0 mu, and also it is a, what is the nature? Means diametric nature. Which nature? Diametric nature. Previously I told you about the diamagnetic. All electrons are paired. We are saying that diamagnetic. Okay. Next about titanium. This is another one-word question. Titanium. Titanium, the atomic number is 22. So the electronic configuration. What is about the electronic configuration? Titanium. Argon 3D. 2 4s2. Clear? Argon 3d2 4s2. Here titanium loses 4 electrons. So this electron is also losing and this electron is also losing. So we get what is the configuration? D0 configuration. Am I right? Which configuration? 3d2. That is 2 electrons from the 3d and about the 4s. 2 electron. So titanium 4 plus, that means it loses for 2 electron from D and 2 electron from S. So we get what is the configuration? D0 configuration. It's configuration. D0 configuration. Here. So the same value is for the mu is equal to root of 0 into 0 plus 2. What's the formula? N is equal to 0. So what's the formula? Mu is equal to 0 into 0 plus 2. Okay. That's the formula. Next about the vanadium. Vanadium 5 plus. What is about the vanadium 5 plus? Atomic number of vanadium is 23. What is the configuration? AR. Sorry. Argon. AR 3d3 4s2. So that means it has 3d subshell 3 electron and 4s subshell having 2 electrons. This is 3d. How much electron? 3d 3. That is 1, 2, 3. And about the 4s subshell. How much electron? 4s subshell 2 electron. It loses 5 electron. That is vanadium 5 plus. 5 plus means it loses 5 electron. So 4s electron 2 loses and also it lost 3 electron from D subshell. So how much electron? 3 plus 2? 5. Okay, that is V5. What's the configuration about? That is D0 configuration. What configuration? D0 configuration. The question may be asked a one-word question. Scandium. What is the configuration of scandium? Sc3 plus. What is the configuration? D0. What is about the titanium Ti4 plus? D0 configuration. What is about the vanadium 5 plus? That is D0 config. These are the one-word question. And also about that, the second step is titanium 3 plus and vanadium 4 plus. Titanium 3 plus. What is the configuration of titanium 3 plus and vanadium 4 plus? Can you say what is the answer? Okay. What is the atomic number of titanium? Titanium atomic number is 22 and the configuration is AR 3d2 4s2. Clear? So titanium 3 plus. Okay, titanium 3 plus means the 3d subshell, how much electron is there? 1, 2, 3d, 2, am I right? 3d2, 2 electrons. And about the 4s? 4s, how much electron? 2 electron. So, our question, titanium 3 plus. What is the configuration of titanium 3 plus? Okay, that's a question. It loses 2 electrons from 4s and 1 electron from titanium. Am I right? It loses 2 electrons from 4s and 1 electron from titanium. So how much? What is the configuration? That is 2 plus 1, 3 electron loses. So that is titanium 3 plus means it is a D1 configuration. Out of 4 electron, 3 electron loses. So we get D1 configuration. Here how can you calculate the number of unpaired electron? Here, the number of unpaired electron is 1. Am I right? Because out of the 3 losers, remaining we have only 1. What is the configuration? We should be correct the formula. Mu is equal to, what's the formula for mu? Mu is equal to root of n into n plus 1, n plus 2, that is B. Bohr magneton, that is mu B, Bohr magneton. Here number of unpaired electron is 1. Am I right? 1 means already 3 losers, remaining having only 1. So how will you write? Is equal to root of 1 into 1 plus 2 Bohr magneton. So what's the answer? We get approximately, that is the value is 1 into 1 plus 2 is equal to 3. That means we get what's the answer? Root 3. We get the root 3. Root 3. What's the root 3 value? The root 3 value is equal to approximately equal to 1.73. 1.73 mu B. Okay. That's the value. The root 3 means 1.73. Here. As per what is the configuration, you should be right, you should be thorough with what's the configuration of Ti3+. That's the question. And about vanadium 4+. Vanadium 4+. Vanadium 4+, can you say what is the configuration? First of all, you should be right the atomic number. What is the atomic number of vanadium? 23. Okay. 23. What's the configuration? Electronic configuration? Ar 3d3 4s2. Am I right? 3d3 4s2. That is the electronic configuration of vanadium. First of all, we are drawing 3d. 3d3, am I right? 1, 2, 3. Next about 4s. Here 4s comes electron. 2 electron, 4s. Here vanadium 4+. Vanadium 4+ means here number of unpaired electron having 3. Unpaired electron 1, 2, 3 unpaired electron, and also including 4s electron. Total 3 plus 2 we have 5. 5 electron. Out of this 5 electron, it loses 4 electron. What's the remaining? Loses 4 electron, 2 and 2. So what's the remaining? That is 3d1 configuration. So vanadium 4+ is, what is the configuration? 3d1 configuration. And also now we wrote that what's the mu value? That is about root of n into n plus 2. Unpaired electron is 1, n is in the 1. So what's the answer? 1 into 1 plus 2. 1 into 1 plus 2, we get root 3. Root 3, the value is 1.73 Bohr magneton. Okay. Okay, due to the insufficient time, we are going fast. We should be do the remaining also. At least 1 or 2 we can be solving. And also, we can be right about the chromium. Chromium is very, very important. Chromium having 3 ions, that is C3+ and also Cr3+ and also Cr2+. Okay, these are the 2 ions for chromium here in the 3D series. First of all, we are writing Cr3+. Cr3+. Can you say what is the atomic number of chromium? Atomic number of chromium is 24. What's the electronic configuration? Be careful about writing the electronic configuration. How will you write the electronic configuration for chromium? Argon 3d5 4s1. Okay, make sure don't mistake here. 3d5 4s1. Okay, now we are trying the D substitution. 3d5 1 2 3 4 5 and about the 4s1 only 1 electron. Okay, here our question Cr3+. What is the configuration of Cr3+? Here having number of electron unpaired electron 6 unpaired electron is there. Am I right? 5 plus 1 6. Out of 6, 3 electrons are lost. So what is the remaining? 3 electron. 1, 2, 3. What's the remaining? Chromium Cr 3 plus means what is the configuration? Out of 6, 3 means we get D3 configuration. What configuration? D3 configuration. Clear? Suppose Cr2 plus means how much configuration? Cr2 plus. Can you say Cr2 plus what is the configuration? D4 configuration. Why D4 configuration? Because the outermost shell having that is 6 electron. Out of 6, 4 electrons are lost. What is the remaining? You get 2. That's it. By this method, we can easily calculate what is the configuration of 3D series ion. Okay. Next about we are write about the manganese. Manganese is also very important. What is the configuration of manganese? Manganese ion. Manganese ion means we have Mn4 plus and also Mn2 plus. Both the two are the very important. That is Mn4 plus, Mn2 plus, and also we have Mn3 plus. These are the 3 configurations for the one way. So you should be write the electronic configuration of manganese. Atomic number of manganese is equal to 25. So what is the electronic configuration? Ar 3d5 4s2 3d5 4s2. Okay, 3d5 4s2. This is the half filled D subshell. This is the completely filled S subshell. This is half filled D subshell. This is completely filled S subshell. Okay. So first of all, we are drawing the D 3d5 1, 2, 3, 4, 5. 3d5 and also 4s 2 electrons. Am I right? This is half filled and this is completely filled. Here our question Mn4 plus what is the configuration? Mn4 plus what is the configuration? Here have we 5 electron, here have we 2 electron. 5 plus 2 how much? 7. Out of 7, 4 electrons are lost. 4 electrons. 7 we are minusing. What is the answer? So Mn4 plus. What's the configuration? D3 configuration. What is the configuration? D3. Mn4 plus means a D3 configuration. How will you get D3 configuration? Can you see? Number of unpaired electron, the D subshell is 5 and number of paired electron and 4 subshell is 2. Then is 5 plus 2 is equal to 7. Instead of the 7, we have lost 4 electrons. 7 minus 4 is equal to we get D3 configuration. What about that Mn2 plus? Mn2 plus. Can you say what is the configuration of Mn2 plus? What's the configuration of Mn2 plus? Mn2 plus is D5 configuration. Out of 7, lose 2 electrons, so we get D5 configuration. What about the Mn3 plus? Can you see Mn3 plus? Out of 7 electrons, 3 electrons are lost, so we get D4 configuration. Like that, you should be calculate all the configuration. Okay, and also very important about the copper, zinc, nickel. These are all important questions for the one-word question. Copper having 2 ions, that is Cu plus and Cu2 plus ions. Here, copper having 2 ions, Cu plus and Cu2 plus ions. These are the 2 ions about the copper. What is the configuration? How will you write the configuration of Cu2 plus? First of all, write the electronic configuration of copper. Copper electronic configuration is 29. Atomic number is 29. What is the electronic configuration? Ar 3d10 4s1. Here copper D subshell is completely filled and S subshell is half filled. Am I right? D subshell is completely filled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 3d10, 4s. How much electron? 1 electron. That is d subshell is completely filled and also s subshell is half filled. This is about the stability of copper. Here copper loses 1 electron. Can you say what is the configuration? Copper loses 1 electron. Cu. What is the configuration? Here having 11 electron. Out of 11 it loses 1 electron, means we get D10 configuration. D10 configuration. Can you say about Cu2 plus? Out of 11 it loses 2 electrons. So 11 minus 2 means we get D9 configuration. D9 configuration. Like that, please, all my dear children, all of you should be doing all the configuration. These are the very important one-word area, and also you should be find out the mu value. What's about the mu value? Already I told you about the mu value. Mu is equal to root of n into n plus 2. Mu is equal to root of n into n plus 2. Here, what's the meaning of n? Number of unpaired electron. Number of unpaired electron. You should be write out the number of unpaired electron. Do it. Okay. Next about the catalytic property. Catalytic property. Okay. Catalytic property. Many industrial processes use transition metals or their compound as catalyst. Many industrial purpose, the transition metals or compound or their compounds are used as a catalyst in such a reaction. For example, one of the reaction we are taking, alkene is converted into alkane. What is the formula for alkene? CH2 double bond CH2, am I right? CH2 double bond CH2, we are taking alkene. Okay, alkene is converted into alkane, that is ENE. This is double bond is ENE, is converted into ANE. This is alkane. CnH2n plus 2, am I right? This is the formula for alkane. Here, first of all, we are taking alkene, that is carbon double bond, one of the hydrogen. Clear? This is an alkene, that is a ethylene molecule. We can take ethylene or ethane molecule. Okay. On reaction, we are taking one of the catalyst. Our 3D series, one of the very good catalyst is used as nickel. Nickel, we are taking the catalyst in the presence of hydrogen. Okay. We are taking which catalyst? We are taking the 3D series nickel catalyst for the conversion of alkene to alkane. First of all, what is happening here? Here having the hydrogen having sigma bond. Am I right? The sigma bond of hydrogen molecule breaks. Okay, that means hydrogen. So the hydrogen breaks to form a bond with d electrons of this nickel catalyst. The two hydrogen atom then partially bond with alkene. Okay, this hydrogen atom breaks, and one of the hydrogen atom is attached here. That means here one of the hydrogen atom is attached, and the other hydrogen also attached here. So can you say what is the product? The hydrogen will be attached here. So what's the product? C hydrogen. Here the attaching species, that is, you can remember like that. Okay, that is CH3. The double bond is converted into single bond. Am I right? Here the double bond is because the carbon valence is 4. Carbon is a tetravalency. Carbon having the 4 valency. So double bond is converted into single bond. Hydrogen. This hydrogen will be attached here. That means this is alkane, alkane, A-L-K-A-N-E. For example, C2H6. We are called as Ethane. Alkane means ethane. Okay. For the conversion of ethene or ethylene to ethane, we are using the catalyst is nickel. Okay, nickel catalyst we are using the conversion of ethane to ethane. Okay, but we are using, and also we have many other processes. For example, the manufacture of sulfuric acid from SO3. Other important purpose also we are using here, the manufacture of sulfuric acid. Manufacture of sulfuric acid from SO3. Vanadium pentoxide, the formula is vanadium pentoxide is V2O5, are used as a catalyst to oxidize SO2. And also we are taking the reaction of V2O5 is reduced to vanadium oxide, that is VO2. And also some more examples are very important for the 2-mark question, that is hydroformylation of olefin. Here olefin we are taking double bond, that is ethylene, or we are taking propene. Here we can be taking propene. Can be written as like that. Propene can be written as here having 1 carbon, 2 carbon, 3 carbon. Okay, 1 carbon, 2 carbon, 3 carbon. We are giving 1 double bond. So the name is propene. What's the name of the compound? Propene. This propene on reacts with carbon monoxide and also H2. Okay, we are using one of the catalysts is called dicobalt octacarbonyl. Dicobalt, that is CO2. Dicobalt, and we are taking octacarbonyl, that is CO molecules with 8. Don't say CO2, okay? This is dicobalt. 2 cobalt is there. Dicobalt octacarbonyl. So, which are the products are obtained means butanol. Butanol means we are taking 1, 2, 3, 4. Here 1 carbon, 2 carbon, 3 carbon, so 4 carbon. Otherwise, we can written as like that. Start with here 1, 2, 3. CHO. Here's a one question, second question, third question, and fourth question. Okay, what's the name of the compound means? Here, number of carbon, what's the number of carbon? We should be count the number. Start with the number is from the functional group. Here, functional group is, here what is the functional group? CHO. What is CHO? Aldehyde, am I right? So, start with number here 1, 2, 3, 4. This is the number. Here, first 4 carbon means the alkane name. 4 carbon, the alkane name is butane, am I right? The 11th class you maybe learn about the butane, am I right? That is 1 carbon means we are saying methane, 2 carbon ethane, 3 carbon propane, and 4 carbon carbon means butane, am I right? The butane, the first position having CHO group. Which question? CHO group. So we are saying butane, the first one having number 1 having the butane, here having aldehyde, that is aldehyde, CHO group means aldehyde. For the IUPAC name, we are saying the name aldehyde means all, we are using all. We are adding the name all, am I right? For example, we are alcohol, we are adding OL. Alcohol, we are adding OL. And aldehyde, we are adding all AL. So, what's the name of the compound? Butane 1-all. What's the name? Butane 1-all. And also, one more product is also obtained. Plus, one more product is okay. Imagine this is one side here we are using methyl. Okay. We can be written as number 1, 2, like that we can give the number. Otherwise, here start with 1, 2, 3. Is also correct. Anyhow, second position we have aldehyde group. Okay, second position we have aldehyde group. So we are giving the number 1 from the functional group. We are giving the number 1, 2, 3. Okay, functional group we are giving the number. So second position having methyl group. This is can be considered as a methyl. So what's the name of the compound? Here we have considered as a methyl. 2-methyl. Number of carbon how much? 1, 2, 3. So 3 carbon is there. So we are saying propane, and one of the first carbon having aldehyde group. Aldehyde group means we are taking the E is dropped here. 1 al. Am I right? 1 al. So what's the name of this compound? 2-methyl propane 1 al. And also the name of this compound we can be again discuss later, because during the organic chemistry taking class we can be learn all the IUPAC's name. I hope that you maybe learn the 11th grade. 11th grade they are having many organic compounds. They have the basic concept also they are having. You may be learn. If you are learning there, you have no doubt. And about the next one is preparation of acetic acid from acetaldehyde. What is the formula for acetic acid? For acetic acid formula CH3COOH. This is the formula for acetic acid. Here, how is acetic acid prepared? That is from acetaldehyde. Formula is CH3CHO. What is the formula for acetaldehyde? CH3CHO. This one reacts with carbon monoxide. The presence of rhodium. That is RH or iridium complex. Okay, the presence of catalyst, we are taking the catalyst, that is this is not a 3D series, this is the 4D series. Okay, rhodium, we are taking rhodium as a catalyst here. So what is the product? We can begin. So what's the product? CH3COOH. What is the product? CH3COOH. So we get acetic acid. CH3COOH means what? Acetic acid. Okay. Next one. Again we are taking the Seeger-Natta reaction. That is a very important question. Seeger is Zeiger. Natta. Catalyst. Okay, one of the important question. And from here we are taking propylene. What's the formula for propylene? CH3CH double bond CH2. This also having the 11th grade. That is the propylene formula. CH3CH double bond CH2. Okay, we are taking N molecules. Okay, we can written as CH3C double bond CH2. Okay, this one reacts with TiCl4. What's the name of this compound? Titanium tetrachloride. And also we are taking triethyl aluminium. The name of the compound is triethyl. Ethyl means C2H5. We have 3. So triethyl aluminium. So here what is the aim is here? The double bond is converted into single bond. Okay, what is happening here? The double bond, here we have a C double bond CH2. Here it is converted into single bond. Okay, so we get CH3, C, hydrogen, CH2. Then we are saying the polymerization, that is okay, here the double bond is break into, it is converted to single bond. We get polypropylene. Okay. Polypropylene. Okay. Next about our topic is formation of interstitial compound. Okay, the formation of interstitial compound. about what is that one means an interstitial compound. The interstitial compounds are alloyed. It's a compound that are formed when small atom like hydrogen, boron, carbon or oxygen. We are taking hydrogen, boron, carbon or nitrogen. Okay, are trapped in the interstitial hole in a metallic lattice. Clear? Here are the small atoms like hydrogen, boron, carbon or nitrogen are trapped in the interstitial holes in a metal lattice. They are usually non-stoichiometric compounds. Okay, already I told you about the non-stoichiometric compounds. The transition metals forms a number of interstitial compounds such as titanium carbide. The formula is TiC, titanium carbide, and zirconium hydride, that is ZrH, and also magnesium nitride, that is Mn4n, etc. These elements are occupying the metal lattice, provide them a new properties. They have some new properties. The properties are very important for the 2-mark question. We should be learning any 2 points. The first property is about the interstitial compound. They are hard and show electrical land thermal conductivity. The first point is they are hard and show electrical land thermal conductivity. They have high melting point, higher than those of pure metals. The third point is transition metal hydrides are used as a powerful reducing agent. The metal carbides are chemically inert. These are the 4 points which you should learn. Any 2 or 3 points is enough. Next, about the transition compound also forming some formation of complex. Formation of complex means we are doing examine. The formation of complex we are taking an example is FeCN 6 4 minus ions. Okay, this is one of the example, and also we are taking cobalt. We are using cobalt NH3. Okay, the 3D series having iron. Iron also making one complex with the help of cyanide, and also cobalt also making one complex with the help of ammonium. Okay, a very good example is for this potassium ferrocyanide, that is K4FeCN6. Okay, from the iron also making one complex, that is we are taking potassium ferrocyanide, and also we are taking that, we can tell the name hexacyano potassium hexacyanoferrate 2. We can be discussed about the next lesson. They have the name, how to say the name. But anyhow, here when the transition metals, that is one of an iron, the atomic number of iron is 26. This iron make one of a complex with the help of cyanide. Here, transition element have the tendency, one of the capacity to form a coordination compound with the species, that ability to donate an electron pair, to form a coordinate covalent bond. Which bond? Coordinate covalent bond. That is, that compound can be donate a pair of electron. That we are saying coordinate covalent bond. The transition metal ions are small. Here the transition metals ions are small and they are highly charged. And also they have vacant low energy orbital to accept the electron pair donated by other group. Okay, the example is FeCN6 and also FeCN6 4 minus, and also cobalt hexamine, that is we are taking ammonia with 6 and giving the charge 3 plus. Okay, these are the today learned portion. And anyhow, my today assignment, what is the assignment means? You should be write the 3 equation is enough. 3 equation, that is conversion of alkene to, one is assignment conversion of Conversion of alkene to alkyne. Alkene to alkane. Okay. Conversion of alkene to alkane. Next step, second one is hydroformylation of olefin. Third one is acetic acid from acetaldehyde. Okay, these are the four reactions. Only reaction is enough. That means only equation is enough. I am telling you write the four equation. So four equation all of you should write. If you are learning and writing means it is very helpful for your studies. Okay. So all of you should write this assignment. Thank you all of you. Thank you. Have a nice day.